Just the hour. We do record these because the intent is to put them up for on YouTube for people to be able to watch later. It normally takes about a couple of weeks, sometimes occasionally up to a month to get up on YouTube, but hopefully these won't be that long. Kiabi, is quantitative also a larger concern for you?
It is, absolutely.
All right. Well then, it is, I suppose, fortuitous that that is what I've prepared for us to do this evening. So, what I hope from tonight is that we have an introduction to three organization styles. You'll see it on the screen here that I have found can be adjusted with very minimal variation to a very wide variety of problems that show up on the quantitative section. So you have rows and columns, you have dashes, or sometimes you'll see it called the slot method. You have line diagrams, and those are just three very, very core organizational styles that we want to practice a lot of. As for rows and columns, whenever you need to track multiple characteristics, I have an example here. Let's say you have like product line A, product line B, and each of those different product lines has like its own price per unit, unit sold, and corresponding revenue. Or maybe like each one has its own like revenue, cost, and profit line, something like that. But like the idea is basically multiple lines, and each line has multiple characteristics that you're trying to track there. Then you got dashes. Really the only difference between rows and columns versus dashes is dashes are just a rows and columns with one row. In fact, you could think of all of this as just rows and columns if you wanted. Multiple entities with only one characteristic. Um, for example, multiple rolls of the dice, that kind of thing. Very useful for probability questions, actually. And then line diagrams. Whenever you've got some type of distance between two endpoints, um, and your result or your mathematics happens somehow in between those two endpoints, that's when a line diagrams are very, very nice. And I have here just a small list. And by the way, if either of you would like, I'm happy to save these slides and send them to you if you want. Did you both get an email from me a few days ago?
Yep.
Yep. Cristal, did you?
I don't believe so.
Okay. Let me just take a moment here. Let me put my email in the chat. So that's my email. And so if either of you want the copy of the slides that we're going to work on this evening, just shoot me an email. I'm happy to send them to you later on. I'll probably be closing out after we're done tonight, but I'll get them to you tomorrow. But what we have here is what I feel is a pretty robust list of content areas that can commonly be solved with each organizational style. So I'm just going to go off microphone here for about 30 seconds, maybe a minute, and I'll let you look over this list. And let me know if you have any questions or if you want some more discussion about any of these content areas or like what type of things they represent. Yeah, like I said, everybody take 30 seconds, a minute, just look over this list.
So are you asking, Chris, if you want us, we want you to double click on any of these? Is that the question?
No, just asking if you want some more discussion about what type of problem is described by any of these content areas.
Okay, got it.
Okay, that's about a minute. First of all, is it Amika? Am I saying that correctly? let me know if you're ready, just whenever you want to get a microphone, and if you want to get a microphone at all, just let me know the correct pronunciation of your name, because I do like to be respectful in that way. Kiabi, do you have any questions about any of these? Want any further discussion or description?
No, I think all good.
Okay. Crystal? Crystal, do you want to have any more description of any of these topics?
No, I'm fine, thank you.
And Amika, let me know. Would you like to have any more description of these before we see some examples of a few of them? All right. Well, let's dive into a few problems then. What I'll do is I have 2 problems for each type of organization, so we can get 2 different exposures to them. And what we'll do is I'll give you all about 2.5 minutes, in one case, probably 3 minutes to do the problem. And then when that time is passed, we will discuss. Please keep in mind that I have chosen, in some instances, some, in my opinion, exceptionally challenging problems. In fact, one of these is a problem that honestly might be better to just look at and say, I'm not doing that, and I'll just move on. But they're all very good examples of one of these organizational styles. And we'll start here. Everyone take a few minutes. Give this problem a try. If you have an answer choice that you'd like to share, go ahead and put that in the chat. If you get stuck and you don't want to be using more time, go ahead and let me know and just say stuck in the chat as well. And whenever anybody is ready, we will begin. Go and take some time, see what happens with this problem. That's pretty close to 3 minutes. I make it anytime if you want to get on the microphone and tell us how you feel about that one, that'd be welcome. Oh, and by the way, to those of you time travelers on YouTube watching this in the future, I intended to give everyone here tonight a chance to solve the problem before we discuss. But when you're watching this on the recording, you should see timestamps or chapter notes where you can, if you need to, just skip to the discussion. I recommend that you don't do that. Do yourself a favor and actually take the time to try the problem before skipping to the discussion. But if that's what you want to do, that's just want you to know that should be available to you. Stahl, what are your feelings on this one? Stahl might not want to share feelings. Koyabi, what about yourself?
It's a bit tough.
Very much so. This was the one I was speaking of when I said this is one where you may just want to look at it and say, no, definitely not right now, maybe not ever. What was it that made it feel challenging? That's an open question to anyone. Koyabi, what made it feel challenging to you? Well, you may have stepped away, but we'll go
No,
and
I'm
dive
here.
in. Oh, okay. What made it
Yeah,
feel
yeah.
challenging?
Just because the initial answer that I got, I wasn't seeing it in the answer choice.
Okay. Crystal, if you're there, did it feel challenging to you as well? Yes. Okay. Can you let me know in the chat? Is there something that made it feel challenging? And I'll keep on the chat while eye on the chat while I'm setting this up. Seem to lack necessary information. That's interesting. Oh, did you get on the microphone to add something? I agree. It does feel there can feel like a lack of information here. This for me is a pretty classic. I believe it's going to be E actually, 42. But we'll see in just a moment. This is a pretty classic setup for a rows and columns approach. I've got two types of beans. So there is my multiple entities. And each entity, I need to talk about uh, how many bushels per acre, how many bushels you got from each acre. We need to talk about just the overall number of acres. And then we talk about just literally the number of bushels. And so those two elements in each one has multiple aspects here. I'm told that each acre of navy yielded 27 bushels per acre. And each acre of pinto yielded 36, so I can put those there. Now, Crystal, here's where it might feel that we have the lack necessary information. It would have been a good guess, I think. We'll talk more about guessing here in just a moment, actually. It's interesting. But number of acres. Fundamentally, we don't know how many acres Dwayne planted of either type of bean. And since the problem gives and requests literal values, I'm not allowed to plug my own numbers into this. I wish I could, I cannot. So we will need variables here. Because I'm creative, I'll call it N for navy beans and P for pinto beans. And what I can do is I can go ahead and jot down a quick note here that the number of acres of the two combined has to equal 70. 70 total acres, 2 types of beans. Now, this problem is actually a really nice disguised rate work question. Any this per that is a rate. We normally think of it as like kilometers per hour or miles per hour, but any something per another thing is a rate. And so we have here our bushels per acre, just as if you had kilometers per hour times the number of hours, that would give you the total kilometers. We have here bushels per acre times number of acres will give us the total bushels. I don't know the total bushels. That's what I'm asking for. But I can just let the relationship fill the rest of the chart naturally. 27 times N, 36 times P. And I'm told that there are twice as many bushels of pinto as navy. So if I take my navy beans, multiply that by 2, that would give me my pinto beans. So my pinto beans there is twice the navy beans. Questions, comments, concerns at this point? All right. Now we have 2 equations, 2 variables. It is an algebra problem now. One of the most common suggestions I hear from students when we get down to this level where we have the 2 equations is to go ahead and solve for one of the variables in this equation, p equals 70 minus n, and to go and substitute that in right there. And that's valid. There's nothing wrong with that. But it's not what I would recommend yet. When I have to do algebra, my first thought is always, let's take whichever element is more complicated and let's try to simplify the more complicated thing as much as possible before I do anything to make it more complicated. And I don't know about you, but for me, it's this equation right here. That's the one that looks more complicated. And that's the one I'd want to try and simplify. And we can. I can divide both sides of this equation by 2. I can then divide both sides of this equation by 9. And that feels a much more manageable equation. I would just pause here for a moment. Any questions, comments, concerns at this point? It actually helps me if you have no questions or no comments, just type in no comment, no question in the chat. Thank you, Cristal. Thank you, Amika. Thank you, Copy. All right. So now we have options. One option is to go ahead and solve for a variable, substitute in, and then build that equation down. However, I want to show you another option here. A different way that you can go about this is you can actually craft your equations to build them for stacking. The GRE test writers have this, what is to me a bizarre love of stacking equations and stacking inequalities, especially stacking inequalities. My wife was a high school math teacher, and I told her about this once, and she's like, wow, yeah, that's valid, but nobody really teaches that anymore. So this may be something that you were just never taught in an algebra class because apparently it's become out of fashion to teach this style of equation solving, but it works. The idea behind this idea of stacking is that you want to have one variable that has the same coefficient, the same number in front of it. So with these 2 equations, I either want to have a 2 in front of the p in both equations or a 3 in front of the n in both equations. In this instance, I'm going to choose to put a 3 in front of the n in both equations. So I'm going to make the p plus n equals 70, multiply everything by 3 there, and get this. Now I can stack my 2 equations. And now you might see why I chose to put a 3 in front of the n. All I have to do now is add these whole equations up together. And 3p plus 2p is going to give me 5p. 3n plus a negative 3n is going to cancel out entirely, and I'll get 210 there. And now I have this equation. I divide both sides by 5. 210 divided by 5 is going to be 42. Now, hold here for a moment. 42 is an answer choice. Don't select it yet. One of the most common traps is just to let you solve for the variable that they did not ask for. So just hold for a moment. Did they ask for the variable P? How many acres of pinto beans? Yes, they did. Our answer is 42, and we are good to go. Questions, comments, concerns? If we decided to guess, I would point out that if I have multiple choice answer choices, I like to guess towards relationships and pairings. This is more often an opportunity on the GMAT than it is on the GRE, because not every GRE question is a traditional 5-answer, choose only one multiple choice. But here, we might notice that I have 2 pairings that add up to 70. 28 plus 42 and 30 plus 40 is 70. So your answer is probably within those pairings. And then you might also think, well, I know that Dwayne grew a lot more pinto beans than the navy beans. So it's actually pretty likely that he planted more acres of pinto beans. So maybe go to the 2 larger numbers in the pairings. And then you'd have a 50-50 coin flip between 40 and 42. And that's honestly decent odds for a question like this, especially if you're going to soak a lot of time into it and not feel like it's going to be worthwhile. Anything before we move to the next problem? Kristal, you feel good about this one now? Good. Koyabi, Amika, how do you feel about this problem now? Can I elaborate on the pairing? Certainly. Anytime I see 2 answer choices that in some way combine together to give me a component in the prompt or some relevance to the prompt, it's highly likely, or I should say more likely, that your correct choice is hiding within that pairing. So here, my answer choices are all numbers of acres. I go back to the prompt. The only thing I know from the prompt about a number of acres is a total of 70. And so if you happen to notice that some of my answer choices total together to 70, we might think, oh, well, those 2 answer choices share a relationship that the prompt said needed to happen. I need my acres to add up to 70. And so you probably want to guess to one of those answer choices where it says they build the relationship that the prompt said you needed to have. Better? Some other examples, Koyabi, might be if you had like a quadratic equation, and quadratic equations are classic for giving you positive versus negative solutions. And you notice that in your answer choices, you have the same number, let's say it's 2, except one answer choice is positive 2 and the other answer choice is negative 2. You'd go, well, I bet it's one of those positive negative pairings because I know quadratics tend to have a positive versus negative issue. And so you might go to that one of those 2 choices then. Anything like that where you notice that a pair of answer choices has some type of relationship dictated by the math of the problem. All right, so now we have seen 1 rows and columns. Let's take a look at one that would use a dashes style methodology here. Let's go, let's go here. Again, everyone take a few moments, give this problem a try, and we'll discuss when I call time. If you're done before I call time, let me know in the chat. Cristal, I think that you are correct. Would you be willing to get on the microphone and tell us how you got there?
So for me, I set it up as an equation.
Go ahead.
So initially it said that 150, so I did like 150 times 60%, so 0.60. Then I set up with like minus y% equals 192. So then when I got the answer as 240, I subtracted the 192 from both sides. That would mean that it'd have to be like 48, and 20% of 240 is 48.
Okay. So what did you get for the 150 times 0.6?
I'm sorry, can you please repeat that?
What did you get when you did 150 times 0.6?
240.
Okay. There
Oh
must
no,
be
I'm
some.
sorry. I'm sorry. No, like I got the answer and it was 90 and then I just added it together to make it 240.
Gotcha. Okay, so
Yes.
150 times 0.6, that's going to be 90. And you say you did 150 plus 90?
Yes, and that was 240 and then um I made the equation like 240 minus y% equals 192 and subtracted 192 from both sides. I would see that it was like 48 would have to like, whatever y% would be would have to make it subtract 48 from 240 and that would be 20%.
Hmm. Okay.
My own fun way of doing math, I guess.
All right. Nicely played. Koyabe, come back to our discussion point a moment ago. Knowing only that this problem deals with percentages, do you notice any pairings in the answer choices? Koyabe, are you willing to get on the microphone?
Yeah, I'm thinking through it.
What number is traditionally associated with percentages?
100,
Percentages are only 100. Do you notice any answer choices that add together to 100?
72, 28,
Yep. And?
80, 20.
Yep. So you at least want to go towards one of those two pairings. Stall, can you come back to the microphone for a moment?
Yes.
This idea of you did the 150 plus the 90.
Yes.
If I wrote that as 150 plus 150 times 0.6, would you feel comfortable with that way to just write that concept?
Um, um,
Like here, the 150 is the 150,
uh-huh.
and the 90 is the 150 times 0.6.
Yeah, I mean, I understand what you're doing, but it's just like for me, I wouldn't.
I'm not saying that you necessarily should.
Okay.
I just want to illustrate that this is what you're doing is taking in two steps this idea of a 150 and then itself plus zero point 0.6 of itself.
Yes.
And so this actually leads to a very common way to write percent change. If you know the percentage, change the percentage to a decimal and either add it on to 1 or subtract it from 1, depending on whether you have a percent increase or decrease. That idea is what leads to another way to visualize a problem like this. I would like to visualize a problem like this using dashes. I know I have a starting point of 150. I know to move from my starting point to the next point, I multiply by 1.6. That's my 60% increase. And then I move from the second point to the third point, somehow decreasing by y%. I just don't know what the y% is yet. Multiply the 150 by 1.6, or as Cristal did, take the 0.6, get 90, add it on, and you get 240. And then see my final result is 192. And now I come back to just a sort of derivation of all of the math that you did here on the right. All this concept of like 240 minus y percent equals 192. That is all just a variation on this idea that percent change can be calculated as the difference divided by the original. And in your method, when you did the 240 minus the 192, you were getting the difference. And so you had 48 as your difference. And then looking at 48 and saying 48 from 240 and saying that's 20%, that's your 48, your difference, divided by the original, and then multiply by 100% to convert it into a percentage. So here you could say 48 over 240. Realize that's 0.2, which is the same thing as 20%. Either way, we end up with A. And I want to be very, very clear. Cristal, I'm not telling you to change what you did. You do not need to change. I'm merely hoping to give you a way to organize all types of problems that look like this and sort of have a way to put the information down before you go to the equations as just something that might help you in the future.
I understand. Thank you.
Of course. Amiga, Koyabi, any questions or requests for me to elaborate on anything? All good. All right. Let's go. Let's go here next. Thank you, Amiga. This problem has several ways that it could be organized. There are two that I personally prefer, but just know that no matter what I show you when we discuss this problem, it's not the only way to do it. Going to take a few minutes, give it a try. I'm laughing at myself right now, and I'll explain why in just a moment. Could I get reactions to this problem either on the microphone or in the chat? Feels like a lack of information again. Trying to see what. Okay. Amika, can you get on the microphone?
Hello, can you hear me?
Yes.
All right, hey sir, how you doing?
Can you elaborate on what you mean when you say trying to see what to isolate?
Yeah, so I'm looking at the percentages that are there, and then also too, I'm looking at how it says the combined total is in ounces, is 12 ounces. So I'm trying to figure out, okay, do I need to now see what percentage equals 12 ounces, if that makes sense?
Mm-hmm.
Looking at like each of the bowls, because it says like fiber X is 55%, and then the max fiber is 70%. So I know that combined in the bowl is supposed to equal 65% of fiber, which is also equal to 12%. So I'm just trying
Yes.
to figure out how do I kind of break it down and what is the best way. So essentially, since they're giving us the percentages, I'm guessing that it'll be easier to first try to see, okay, how do I get to 65% if I have one bowl that's 55%, the other that's 70%?
So it feels like we have like two competing ideas.
Yes,
Like
exactly.
you've got a 70% and a 55, and they're fighting each other, and somehow they have to coordinate to get to 65.
Yes.
Yeah. On a side note, what's the baby's name? Or you don't. This is going up on YouTube, so if you don't want to say, don't
Oh
say.
no,
But
it's fine. It's
yeah.
my son Shiloh. It's my newborn.
Oh, adorable.
Thank you.
Congratulations, by the way.
Thank you very much.
Yeah. So, uh, interesting. Okay, so Crystal, you feel like it's less than 6 ounces. Can you elaborate on that? Don't think I should.
I don't have
That's
like
fair.
a strong rationale, honestly.
Okay.
I just,
That's,
in because for me, I had issues like setting up the equation. And
mm-hmm.
so when I was just thinking to myself, like, it's not, saying whether or not it's like half. So I did like the very basic thing of just like adding the two up and dividing them by two and noticing that it just didn't seem like it could be half.
Okay, what did you add together and divide by 2?
Oh, the fiber content.
55 plus
Because,
70 and divide that
yeah,
by 2?
yes, it was like 62.5.
62.5.
Yeah.
Hold that thought. Hold that thought. I noticed that there's a lot of discussion of going straight to equations, and one thing that I hope that you take from this tonight is that at no point did I push myself to go straight to an equation. In so many problems, I want my point of view to be the algebra can wait. I'll deal with the algebra later. I need to organize this information. And that's scary because we're under a lot of time pressure on this test. You have to do these problems fast, fast, fast. So it is scary. But if we practice it, we actually increase our overall solution speed. Kuyabi, please get on the microphone.
I tried setting up two equations.
Mm-hmm.
The first one was 0.55x plus 0.7m equals 0.65m, and then x plus m equals 12. So then,
Oh,
yeah,
all
I
right.
was just gonna try to plug in one of them and solve
Yeah,
for
yeah.
one of the variables.
So hang on. So if you go the equation route, you're almost there. 0.55x plus 0.7, you said m, like m for max,
Yes.
and that equals 0.65 what?
0.65.
Percentages never exist in isolation. It's 55% of x. It's 70% of max. But it's 65% of what?
Oh, of x plus m.
There you go. And then you also have that other equation that you mentioned, x plus m equals 12.
Yep.
Well, now here you have your two equations, two variables, so you could go through that process there. The reason I called you at the end, you may have noticed, I don't know if you noticed, but I started smiling a little bit. Here's why I'm laughing at myself. I swear to God, I did not do this on purpose. But Kiabi, do you notice that we have pairings in the choices again? What do you know about the total ounces? It's 12, right?
Yes.
Do you notice any choices where two of these choices add together to be 12?
8, 4, 9, 3.
So it's probably in those pairings. And now if we can decide whether we want to be on the high end or the low end, we've actually got a pretty good shot at this problem. In point of fact, Cristal, in just a moment, I'm going to come back to you because your idea of judging high and low end actually doesn't guess eliminate. It completely solves through elimination, at least getting us down to a 50-50 shot. But that said, Amika was talking about, it felt like I have two things that are kind of fighting. You had fiber X at 55 and you had fiber max at 70, and like they're competing and somehow they sort of coordinate to get us to 65. This is our classic line diagram idea. Two endpoints that somehow coordinate to meet somewhere in the middle, where something happens in the middle between them. Cristal, get on the microphone again, please.
Yes.
Now you said when you added 70 plus 55 and divided by 2, you got 62.5. Am I correct in that?
Yes.
What you just described is what the result would be if we used completely equal amounts of each. If you used 6 ounces of fiber X, 6 ounces of fiber max, you land at 62.5. Dead in the middle. Do we land dead in the middle?
Oh, no.
No. We land here. Which means right off the bat, I know 6 is wrong. Because we did not land dead in the middle. But now, what do you suspect we used more of?
I don't know. Fiber X.
Other way around.
Oh, it's fiber
Whichever
max.
whichever your result gets pulled towards,
Okay.
62.5 is what if we're dead even. And every movement towards fiber max is using more of fiber max. So we used more of max, less of x. They asked for x. So that tells me that 8 and 9 also have to be wrong.
Okay.
All good there?
Yes.
All right. And now at this point, it's just trying to determine the portions of this competition. And basically what's happening here, I call this a tug of war. The GRE books from Manhattan Prep call it like teeter-totter method. In fact, I think a lot of sources call it teeter-totter. I've always felt the tug of war is a little bit more intuitive to me for what happens here. Because basically, if I think of this as tug of war, Team X wants to be at 55. And everything that gets pulled away from Team X is something that Team Max pulled away from them. So every element of distance away from that 55 to my 65 is what Team Max grabbed. They're pulling in that direction. So I can say here, in terms of my balance, and here we're going to have to go to a ratio, Team Max is pulling 10 away from what Team X would have wanted. Conversely, everything that goes away from Team Max is what Team X is pulling to their end. And Team X is pulling 5 away. You could use it in terms of pull analogy, or you could just memorize the fact that your 10 and your 5 are always flipped in this picture. That is just something that could be memorized because it's always this relationship. I have 10 units of pull, 5 units of pull, that is 15 total units. That creates my ratio. That tells me that I used 2 parts max for every 1 part X for 3 parts total. I put this together in a 2-to-1 ratio. These are my ratios. Now I need to figure out my actual number of ounces. And the only thing I know about the number of ounces is that I had 12 total ounces. Well, how does this ratio of 2 to 1 to 3 generate 12 total ounces? If I multiplied everything by 4, that's the only way this happens. 3 times 4 is 12. 1 times 4 is 4. 2 times 4 is 8. Which one did they ask for? They asked for X. I'm going to hold here. Comments, questions, concerns?
So you're saying that it would always be 10 and 5, and then from then on you simplified?
Yep. I build this tug of war diagram. It's 10 units of pull in one direction, 5 units of pull in the other. So it's always going to be a 10 to 5, which reduces down to a 2 to 1 ratio. 2 parts of max, 1 part of X, that's 3 total parts. And then we build our number of ounces off of that ratio.
Okay. Thank you.
Now, I'd like to show you another way to visualize this. This one can also be used as a visualization, sort of a variation on the dashes. Occasionally we have problems where we have some target and neither of my individual components are hitting that target, but the individual components give me surpluses and deficits. Max is too high. Max is giving you too much. X is too low. X is giving me too little. Sorry. I meant to write target. This is why I can't start writing while I'm still talking. My target is 65. If I'm looking at deficit versus surplus, I know that team X is my deficit. They're giving me too little. And team max is my surplus. They're giving me too much. But the question now becomes how much too little? How much too much? And team X is giving me a deficit of 10. Every single part of X that I use is 10 below what I want. Team max is giving me a surplus of 5. Every bit of max that I use is giving me too much. And the idea is I don't want too little. I don't want too much. I want Goldilocks. I want the two things to balance out. How do I balance this out so that I don't have too much deficit and I don't have too much surplus? If I put in one more surplus, now my surpluses and my deficits cancel each other out. I won't have too much. I won't have too little. It'll be just right. And this is another way to see that my ratio has to be 2 parts max, 1 part X, 3 total parts. For my total ounces, 12 total ounces, 4 and 8. That's another way to see it. Questions, comments, concerns from anyone? If there are no questions or concerns, just let me know that in the chat too, please. All good from Cristal, Koyabe, Amika. How would I have guessed based on pairs? In this case, Koyabe, all I would have known to do is not guess 6. This thing where Cristal started in saying dead even would be 62.5. I'm actually at 65, so I know you used more max and less X. That isn't a guess. That is a literal, like, that is mathematical certainty. Your answers now cannot be 6, 8, or 9 because you have x has to be less than half of the 12. And after that, both my 3 and my 4 had pairings. 3 is paired with 9, 4 is paired with 8. It would have been fantastic if choice A had been 1. If choice A is 1 and I do this, I'm definitely guessing the 4 because the 4 has a pairing. The 1 has no pairing. There is no 11 counterpart here. That would have been a time where I could have made a better guess based on pairing. Here, the pairings honestly don't get me any more than the I know I needed to use less X analysis. But I wanted to point out that the pairs did exist. Tough, yeah. I am pulling challenging problems for us tonight. These are not easy. Other comments, questions, concerns? All right, well, I realize now that in my quest to show you all different diagram styles, I've chosen problems which never offered us a particular opportunity that I want to make sure that you see. We are getting close to the end of the hour here, so I'm not going to do a timed attempt on this. I'm just going to give you about 30 seconds to read, and then I'll start talking. Take a few moments to read. This problem is in one specific way completely different from any of the others we've looked at tonight. I am never given any numbers. I am never asked for any numbers. And I wanted to make sure I showed you an example of this. If you are not given and not asked for actual numbers, you can pick, and you probably should. For the organization here, I'll have women, I'll have men, and I'll probably just have the total number of people in the group. That's a pretty common setup. I will have the number of people, just the number of women, the number of men, the number of people in the group. And I'll have how many of them speak Spanish. Do we need to talk about how many don't speak Spanish? It's never mentioned, so I'll leave that off for right now. Now, the tricky part here is knowing where to plug a number. And the idea behind plugging numbers is choose the number for where you have the most directions to act. 4/5 is going to apply to the women. 3/4 is going to apply to the men. This 40% as many men as women, this is taking 40% of the women, and that's how many men are in that group. Since I've got more stuff that applies to women than to men, I'm going to choose for the number of women, and I'm going to go ahead and just make that 100. Probably a larger number than I need, but I know it will work well with percentages. I know it will work well with fifths. I know it will work well with fourths. If there are 100 women, that means there are 40 men, for a total of 140 people. 4/5 of the women speak Spanish. 4/5 of 100 is 80. 3/4 of the men speak Spanish. 3/4 of 40 is 30. That would be a total of 110 Spanish-speaking people. They want to know what fraction of the whole group is Spanish-speaking. That would be 110 over 140, which you can put in here as 110 over 140, or you can reduce that down and write it as 11 over 14. Either would be acceptable on the test. Perhaps that was too fast, and if so, I apologize. but we were pushing close to the hour, and I wanted to make sure that you saw an example of just how beautifully efficient recognizing an opportunity to use our own numbers can be. Anyone have questions, comments, concerns? Thank you, Crystal. All right, my friends. Well, I will put my email in the chat again. Um, again, I'm happy to send a PDF copy of all the slides with the notes on it to you whenever you wish. Just shoot me an email. I'm happy to run that your way. Excuse me. And other than that, thank you all. A small group, but I really appreciate it when people are able to get on the microphone and very active in the chat, and you all have been. It makes my job a lot more enjoyable. And so I really enjoyed working with you tonight. Um, and hopefully, maybe I'll see some of you in the future in a class or something like that. That'd be great. I actually do these free prep hours usually about once a month. So keep an eye out for other free prep hours. You might be seeing me again. And other than that, I wish you all the very, very best of luck. Amika, congratulations again on your newborn. Um, as someone who has two kids of my own, uh, have some fun with that. And like I said, good luck to everybody. I'll stick around. I'll stop the recording here. But if anybody has any questions or last minute concerns, go and raise them.